Good morning to all. Today we are discussing about counter type analog to digital converter. It means that this analog to digital converter circuit implementation we are using the counter based on this condition. This analog to digital converter we are called as counter type analog to digital converter. Okay, and sometimes this counter type analog to digital converter we are also called as ADC using DAC. It means that this counter circuit implementation we are using the digital to analog converter. Okay, and in the last class we studied about flash type ADC. In that circuit we want to obtaining the 3-bit digital output. We are using the 8 comparators. Okay, and for example now I want to obtaining the 4-bit digital output. In this condition we are using the 16 comparators. So here the circuit complexity is increases. We need to avoiding this issue. We are studying the counter type analog to digital converter. Okay, the circuit diagram of the analog to digital converter I show in figure. Okay, here we are consider the analog input signal, and the analog input signal we are mentioning as VA, and this signal is given to input of the comparator. Okay, here we are using the comparator, and this analog signal is given to input of the non-inverting terminal of the comparator, and this comparator output is given to input of the AND gate. Okay, and here the other input of this AND gate is the clock signal. Okay, and this AND gate output is connected to input of the binary counter. Here we are using the binary counter, and this binary counter can be counting this clock pulses. It will providing the binary output. Okay, and these output signals are given to input of the digital to analog converter. Okay, so this digital to analog converter can be converting the given digital bits into analog signal output. Okay, so here that analog signal output we are assuming as VD, and this output signal is given to input of the inverting terminal of the this comparator circuit. Okay, and here we need to reset this binary counter by using the reset pulse. Here we are using the reset pulse. Okay, and now here the clock pulses are counted by this binary counter, and these clock pulses are go through by enable the this AND gate. Okay, and this AND gate is enabled by high output of the comparator. Okay, and now with respect to this clock pulse, this binary counter can be providing the binary output. Okay, so these binary outputs we are assuming as a digital output. So in this binary output, so this is we are assuming the MSB bit, and this is we can assuming the LSB bit, and here we will get the digital output. Okay, and now we need to understanding the operation of this counter type analog to digital converter. Okay, with respect to this reset pulse, we need to reset the binary counter to 0. At that time, this binary counter can be providing the binary output is 0 0 0 0, and this binary outputs are given to input of this digital to analog converter, and this digital to analog converter can be providing the analog output, and the analog output voltage is for example 0 volts, and this signal is given to input of the this comparator, and now here we are apply the analog input signal. Okay, and this comparator can be comparing this analog input signal to this digital to analog converter signal, and here the non-inverting terminal voltage is higher than the inverting terminal voltage, and it will provide in the positive saturation voltage. Okay, and this positive saturation voltage we are assuming as a logic 1. Here this logic 1 output is given to input of AND gate. With respect to this logic 1, this AND gate can providing the clock pulse, and these clock pulses are given to input of the binary counter, and again the binary counter can be counting these clock pulses, and it will providing the binary output, and these binary outputs are given to input of this digital to analog converter. Okay, and here we need to observe in the one important point is here we are applying the analog input signal, and that input signal is greater than the this digital to analog converter signal voltage. At that time this binary counter can be counting this clock pulses and it will providing the binary outputs. Okay, for example here we are assuming the analog signal voltage is 2 volts. Okay, and initially this binary counter can be providing the output is 0, and with respect to this digital to analog converter we will get the output is 0 volts, and this 0 volts is going to input of this comparator. At that time this non-inverting terminal voltage is higher than the this voltage and will providing the logic 1. Okay, and with respect to this logic 1 this AND gate again providing this clock pulses, and these clock pulses are given to input of this binary counter, and this binary counter can be counting these clock pulses and it will providing the binary output, that is 0001. So in this process the binary counter will be providing the binary output. Okay, and for example here we are assuming the condition is VA value is less than the VD. It means that for example here we are assuming the analog input signal voltage is 1 volt, but the digital to analog converter output is 2 volts. At that time this comparator can be comparing the inverting voltage to the non-inverting voltage and will providing the negative saturation voltage, and that negative saturation voltage we are assuming as the logic 0. So with respect to this logic 0 this AND gate is not providing any clock pulses. So here the binary counter stops counting with respect to these clocks because here the clock pulse equal to 0. Therefore the binary counter will be stops that counting. At that time what are the values will be available at the output of this binary counter, that values we are consider them our required digital output. Okay, in this way we will get the digital output from this given analog input signal. Okay, and again we want to give them another analog input. At the time again we need to reset the this binary counter, and we can follow the same procedure for obtaining the this digital output. Okay, and now we are discussing about advantages and disadvantages of counter type analog to digital converter. Okay, coming to the advantages, first one is simple construction, and second one is easy to design and less expensive, and third advantage is speed can be adjusted by adjusting the clock frequency, and the fourth advantage is faster than the dual slope analog to digital converter. Okay, so these are the advantages of the counter type analog to digital converter, and next we are discussing about disadvantages. Okay, in this disadvantages, conversion time depends on input signal amplitude. It means that based on the input signal amplitude the conversion time is increases. For example here we are consider the analog input signal, and this analog signal have the maximum amplitude. Okay, so here with respect to the digital to analog converter it will providing them some analog signal voltage. That analog signal voltage is VD, and this signal amplitude we can assuming VA. So this VD signal it will take more time to reach this voltage. At that time the conversion time is increases. Okay, this is the one of the drawback of the counter type analog to digital converter. Okay, thank you.